So in this video, I'm going to give some examples of constructing truth tables for some more complex statements that involve conditionals and biconditionals. So for example, let's do number one here. Let's say we want to say, P if and only if Q, and see how that might impact Q. So P if and only if Q implies Q. Alright, so I have two simple statements, P and Q, so I'm going to need a column for each of those, and 4 rows, true, true, false, false, and true, false, true, false. Okay, so I need to evaluate this biconditional first. That's P if and only if Q. So a biconditional is true when the component statements have the same truth value. So that'd be here and here. Here they're both true, here they're both false. Now everywhere else it's false. And I want to see then how that works when I construct a conditional statement with Q. So in this case, I really don't need this column anymore. This is going to be my antecedent, and this is my consequent. Now a conditional statement, remember, it's only false if I can find a place where this is true, but this is false. And so where this is true, but this is false. Well, that's not true here. As in this last row, this is true, but this is false. So that means I'm going to have a false entry. Now, when the antecedent is false, the conditional is true. So this is the only place where that's false. So there is the truth table for this somewhat more complicated statement. All right, let's do another example. If P, then Q, and P. So I'm going to evaluate this and then see if that implies, or when that implies Q. So I have my simple statements P and Q. So true, true, false, false, and true, false, true, false. And let's see, where do I want to start? First I want to do the conditional statement P implies Q, and then I'll look at that as a conjunction with P. And then finally I'll look at that as a conditional, P implies Q, and P as a conditional with Q. So this is going to take several steps. So first of all, the conditional. This is true, except in this case where I have a true antecedent and a false consequent. So true, true, true. All right, now what happens when I take a conjunction between if P then Q and the simple statement P? So I'm looking at a conjunction. I'm going to ignore this row and say that a conjunction is true, this and statement, whenever the components are true. So here, when both components are true, but not here, nor here, nor here. All right. So, all right. Finally then, I want to form a conditional between this statement and the simple statement Q. Again, with a conditional, I'm looking to find, is there a case where this is true and that's false? If so, then the entire conditional will be false. Otherwise, it's true. So, is there a place where this is true, but this is false? Well, not here. And in fact, in all the other rows, the antecedent, this whole statement here, is false. Remember, in a conditional, when the antecedent is false, the entire statement is going to be true. So I end up with all truths. This is called a tautology. So that is a tautology is a compound statement that is always true. So, no matter the combination of truth values for its component statements. Okay, let's do another example. Let me move this down so we can see. And this will be P and Q, so that's a conjunction. And then let's combine this with not P or not Q. So this is a disjunction, it's an or statement. This is a conjunction, an and statement, and I'm combining those with an and. So I'll need P and Q, true, true, false, false, true, false, true, false. And first I want to form the conjunction of P and Q. That's true when both are true and false otherwise. And I'm going to add a column for not P and another one for not Q. So this is just going to flip these signs of P to false, false, true, true. And this will flip the signs of Q to false, true, false, true. So then when I take the disjunction, not P or not Q, a disjunction is true when one or the other or both are true. So not here, because both are false, but here, here, and here. Okay, so now I have this piece and this piece. And so finally I can look at this conjunction of P and Q with not P or not Q. Okay, so I want to focus in. I'm really just looking here and here. And this is an or statement, so I can have one or the other or both. So one or the other. Oh, I'm sorry. This is an and statement. So I need them both to be true. That's not true here because I have a true with a false. So this is false. Here I have a false with a true. Again. And false with true, false with true, false with true. So for the and, they needed to both be true in order for the conjunction to be true. So I end up with all falses. So here I had all trues, that was a tautology. Here I have all falses. That's called a self-contradiction. And so this is just always false. It's false for every combination of true and false for the simple statements. Alright, that's it for this video, and in the next video I'll talk about equivalent statements.